Step-by-step exam solutions. Okay, math class, training you to excel. Subscribe, like the video, share the link of this video with your friends. Click for the alert so that you receive the next presentation. Please drop your comment to improve our services. Okay, math class, present steps to exam success. Step 1, pray. Step 2, plan. Step 3, prepare. Step 4, preview. Step 5, perform. These are 5 steps to achieve success in an exam. Okay, math class, present step-by-step exam solution to solving simultaneous equations using determinant method. In this presentation, we'll be studying number 1, forming a matrix equation. Number 2, we're going to see using Cramer's rule or any other method to solve simultaneous equations. Then number 3, we are going to see solving simultaneous equation using determinants. The objective of this presentation are: number 1, form a matrix equation using the coefficients of x and y. Number 2, use the Cramer's rule to solve a system of linear equations. We'll go to the next slide for proper presentation of the topic, solving simultaneous equations using determinants. Here we have 2 equations to solve. The first equation is this: A1, B1, and C1 are constant. The variables are x and y. The second equation, A2, B2, and C2 are constant. The variables are x and y. We can solve these 2 equations using elimination method or substitution method, depending on our choice. Now, to solve this equation, when we solve this equation using elimination method, this will be the value of x we are going to get. You can try that by solving by elimination method or any other method. That's what you are going to get as the value of x. Looking at this value, you can see our focus is this first part here and this second part here. The whole of that equation looks like what we are very familiar with. The numerator is like a determinant, and the denominator is like the determinant also simplified. So now, this first part here is the leading diagonal. In this leading diagonal, this will be the position of C1, and then that will be the position of B2. Now, this is the second diagonal. For that second diagonal, that will give me the position of C2, and that will give me the position of C2, and this will give me the position of B1. So we have the numerator, which we call the determinant for x. So now, that means we are going to use that to actually simplify the numerator. Doing that, we are going to have that numerator, instead of having this thing that looks complex, can be simplified into determinant form by giving us this expression we have here. I've explained how we arrive at that expression. So now, we are now going to also divide that by the lower part, the denominator. This is the leading diagonal. We can write that as A1, and then this side as B2. And then this is the second diagonal. We can write that as A2, and then we have B1. This is B2. Now remember, this is the second diagonal. That direction is minus. And this is the leading diagonal. That direction is positive. So now we have that. And now we can actually look at how do we handle this now Using that, we can write the denominator in form of determinant. And that will give us the determinant x value will give us the numerator, the determinant of x divided by the denominator, this denominator here, which is this, the determinant of the coefficient of x and y, which is a1, b1, a2, b2. So now that we have established that, so we can now also now look at the second aspect, the value of y. The value of y will give us what you are seeing on the screen now. Handling that further, remember as I explained, looking at the denominator, we can form a determinant with the denominator. This is the leading diagonal. That leading diagonal, we're going to write it as C. We're going to write that as A1, then C2. That's the leading diagonal. And then we're going to write the second diagonal as A2, C1. That is that. Now, please take note that the denominator is still the same thing with the first one here. So we don't need to be explaining that again because it's the same. So now we're now going to simplify that as this you are seeing on the screen now. This numerator is exactly the same as what we have here. So now that we have done that, we are now going to divide that by what we did in the first part here, the same value here, we're going to write here. So now doing that, we're going to have that value as that. So now cleaning that up, then we're going to have the value of y will be equal to the determinant of y divided by the determinant. Now, the next is for us to look at what are the steps that we are going to follow if we are to solve this equation. So now, the steps are, number one, the first step we are going to take is to form a matrix equation using the coefficient of x and y. And that's what we did here. Now, that's what we did using this and this to get this and this. So now, the next is to find the determinant of A. That's number two, find the determinant of A. And that's what we have done here, determinant or this or this. So that's what we have done here. You find that determinant of A. Then number three is to find the determinant of AX. Now that determinant of A, that is the numerator, is formed by replacing the value of A. You see the value of A in the main determinant. Look at here. That's the value of the constant C1 and C2. So we replace that A1, A2 with C1 and C2. So the value, that determinant we got by replacing the x values with the constant value is what we call the determinant of x. So now the same thing we do for determinant of y. Which one do we replace? We are going to replace B1 and B2 with a constant value, C1 and C2. So now, having done that, the next is to find the value of x and then find the value of y. These are the simple steps we are going to take if we must solve equations using determinant. Now we are going to go to the next slide to solve examples. Now, solving simultaneous equations using determinants. So now we are going to have the questions. Then we have these two equations we have here. I have x, the first equation, and the second equation. So now we have the first equation and the second equation. Now we are now going to try to form the equation. So now we'll start the solution. Now we have the equation already formed, but I will take time to explain that. The first we are going to see there are three matrices here, 1, 2, and 3. These are the matrices that form that matrix equation. Now, how do we get each of them? Now, look at the first equation here. What are the value of the coefficient of x is 2 and the coefficient of y is 1. This is 2 and y is 1 here. So now do the same thing here. The coefficient of x is 5 and that of y is minus 2. So you have 5 and then minus 2. So that gives us the minus 2. That gives us the matrix that will form using the coefficient of x and y. The next is we have the x value, x and then y. So that gives us the matrix using the variables. Now solving, the constant value is, the first is 11 and the second is 5. Then we have the constant value. That's how we got this matrix equation using the coefficient of x and y and the x and y itself and the constant 11 and 5. So that's how we form that matrix. Having formed the matrix equation, the next is for us to start solving this matrix equation. Now, the determinant is given by this. So that's how to find the determinant of this one here. So now that we have that, already we know how to find the determinant. We find the product of the leading diagonal. But then and find the product of this. Remember, this direction is minus. So when you do that, minus 2 times 2 will give us minus 4. And then 5 times 1 is 5. Remember that direction is minus, so that gives us minus. So therefore, the answer will give us minus 9. So that's how to evaluate that determinant. So therefore, we now get the value and then put down the value. Then we have the value of the determinant is minus 9. So we do the same thing for the determinant of x. Remember, to find the determinant of x, we need to replace the first value here, 2 and 5, with the constant value. So, and that's how we got this to be 11 and 5, and no more 2 and 5. So we have that to replace. Then we'll find the determinant. How do we find the determinant? This, the leading diagonal, will give us a minus 22. Then the second diagonal will give us also minus 5. Remember, this direction is minus. Then that will give me minus 27. So that's how we evaluate that. Having explained that, then I can now put in the values. Then we have those values now expressed there. And then simplifying, we have that as minus 27. Now we're going to find the determinant of y. What should we do? We're going to use this constant value to replace the y part, the coefficient of y in this equation we have formed. And that's how we got 11 over 5 instead of 1 and minus 2 that you can see here. We now have 11 and 5. So because we have to replace the y values with the constant values. So now, solving that, we are going to have the leading diagonal give us a 10. And this direction is minus, giving me minus 55. Simplifying, I have minus 45. So now we have that solved. We can now write that down. We have that will give us a 10 minus 5 times 11, which is minus 55. 10 minus 55 is minus 14. So now we're now going to solve the equation now. So the x value, remember x value will give us the determinant of x, which we have obtained here as minus 27, divided by the determinant, which we have gotten here, this as minus 9. So we have minus 27 divided by minus 9. Now, minus 9 into 1, minus 9 into this will give us 3. So therefore, the answer we get there will be 3. So the value of x is 3. Now we are going to do the same thing for value of y. So now we are going to divide the determinant of y that we obtained here, that is this value. We are going to write it. Then we are going to divide it by this and this also. So that's why we are having here minus 45 divided by minus 9. So now when you do that division correctly, This will go into 1, this will go into 5, giving us our answer as 5. So therefore, solving this equation, we can see clearly that the value of x is 3 and the value of y is 5. That gives us the solution of this equation. So please remember to subscribe, like the video, share the link of this video, click for notification so that you receive the next video when released. We move to the next slide for the second example. So now in the second example, we try to set something different from this using a fractional equation. So now we have this fractional equation and we want to solve that. So usually, again, the first step is to form the matrix equation. But in this case, we are having a fraction. We're having a fraction in this case. So since we're having a fraction here and a fraction here and a fraction here, the first step is to clear that fraction. To clear the first one, the LCM of 2 and 3 is 6. So you multiply the first equation by 6. You are going to have 6 over 2x plus then 6 over 3y will be equal to 6 times 2. Simplifying this, you have 3x plus 2y is equal to 12. So that's how we got this equation, by clearing the fraction, simplifying that expression to make it a little bit easier for us to handle. So we do the same thing for the second part. What is the LCM of 4 and 2? Of course, the LCM is 4. So multiply the whole of that in this equation by 4. You are going to have 4 over 4x minus 4 over 2y is equal to 1 times 4. This will cancel this, giving us x minus 2 into this one, 2 into this 2, giving us minus 2y is equal to 4. So now that means the second equation, when simplified, will give us x minus 2y is equal to 4. Then we need to solve this equation now. We form the determinants, the matrix equation. So now, of course, I've shown you how to form the matrix equation. Using the coefficient of x here and here, you have 3 and 1. Then using that of y, 2 and minus 2 here, you are going to have this minus 2 and minus 2. So we have formed that. Then using the variables of x and y, we get this. Then this constant value will give us the constant matrix equation matrix we have there. So now we can now start solving this. Remember the steps. So the first step here is to find the determinant of this. So that's the first step there, to find that determinant. So we are going to now write the equation, we have that. Then multiply this, which is minus 6. Multiply this, which is minus 2. Then that means the determinant of this equation is minus 8. Now that I've seen the determinant, the next is to replace the x values here with this constant value to get the next determinant we're going to solve. Now, let's do that now. So now that determinant of x will now is obtained by replacing the x value. Remember, the x value is replaced by this value here is replaced by 12 and 4. That's how we got this. So now that we have that, we can now find the determinant. This direction is the leading diagonal, is minus 24. Then the second diagonal, remember this direction is always minus. That will also give us a minus 8. So now you have that as minus 8. Then when you now add the 2, you are going to have the answer as minus 32. Then we repeat the same thing for the determinant of y. So what do we do in the case of determinant of y? We are going to replace this y value with a constant value here. So that's how we got this. Instead of 2 and minus 2 we have here. That's how we got that. So now that we have that stated, we need to find the determinant of this. And how do we find the determinant of this? We multiply the leading diagonal. If you do that, the leading diagonal is 12 plus. This direction is minus. 1 times minus 12. 1 times 12 will give us minus 12 because that direction is minus. So now that will give us the answer as 0. So now for that determinant, we are going to have 12 minus 12 will be equal to 0. Now, using the Cramer's rule we are going to have the x value will be the determinant of x divided by the determinant. So now, having done that, we now make our substitution. What is the determinant of x here is minus 32. We write it here. And what of the other, this one, the determinant, minus 8. We write it here. So now we have that. So we can now divide minus 32 by minus 8. Of course, you know that your answer here will be 4. So we now repeat the same thing for the value of y. For the value of y, we're going to divide the determinant of y, that's determinant of y, which we have here is 0. We put it here, and then the determinant itself, we put it at this in this position. So now we're now going to evaluate that. We're going to have 0 divided by minus 8. Any 0, when you divide a 0 by any number, your answer will be 0. So now we've got the value of x is 4 and the value of y is 0. So now we have solved this equation. We have solved this equation. So there's an assignment for you. Following the same process or the same method of what you have done, please solve this simultaneous equation. That's an assignment. And give me your answer in the comment section. Let me see whether you are correct or not. That brings us to the end of this presentation. Remember to subscribe, like the video, share the link of this video with others. Click for notification so that when the next video is released, you will be alerted. Thank you for watching.